Hello students. In the previous lecture we have discussed about the true solution. Now in this lecture we are going to discuss about the heterogeneous mixture, that is suspensions and colloids. Okay, before discussing this I am going to show you the true solution, suspension and colloids. See, in this glass I have taken water plus sugar. It is transparent in nature. So this kind of solution is called as true solution. If you dissolve sugar in water, salt in water, it gives a clear solution. So this is transparent in nature and it is homogeneous mixture, because solute particles are uniformly distributed. Today we are going to discuss about suspension. Suspension, the best example of suspension is take some sand and dissolve in water. Will the sand dissolve in water? No. See, the sand particles are settled at the bottom. Okay? So if I just shake it, the sand particles will again come up. See, sand particles are settled at the bottom. So it is a heterogeneous mixture. Okay? And the solution is not clear. So it is a translucent solution. Clear? So we are going to discuss about the suspension. What is suspension? A suspension is a heterogeneous mixture. See, sand and water is a heterogeneous mixture. Yeah, it is a heterogeneous mixture in which the solute particles do not dissolve. In this, the solute particles are not dissolved and suspended throughout the medium, and it is suspended. You can see the solute particles. It is suspended. It is not completely dissolved. You can see the sand particles on the water. So it is suspension. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk medium. Example: sand in water, chalk powder in water, bleaching powder in water, dissolved calcium hydroxide in water, or wheat flour in water, paint in water, magnesium hydroxide in water. So this kind of mixture is called as suspension. What are suspensions? Suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk medium. Now properties. So looking at this solution, we are going to discuss the properties of suspension. Tell me, first point, it is homogeneous or heterogeneous? It is heterogeneous. Okay, first point is it is heterogeneous. It is heterogeneous. Next, the solid particles. Can you see the solid particles or particles through the naked eye? Yes, we can see because they are settled at the bottom. Okay. Now I am not having the glass rod, I am using the pen. See, if I mix it, the particles are coming up. Clear? So solid particles, a suspension is a heterogeneous mixture. The solid particles of suspensions are so large in the size, more than 10 to the power of -5 centimeter, that they are visible to the naked eye. We can see through the naked eye. The particles of the suspension scatters the beam of light passing through it and makes the path visible. Suppose if you pass the light through it, if you pass the light through this suspension, what will happen? The light will scatter. Light will not go straight. See, when the light will not go straight, it will scatter. Means it is showing Tyndall effect. It will show Tyndall effect. True solution, the light, if you pass the light in the true solution, in this solution the light will go straight. But when you pass the light in the suspension, the light will scatter. It will not go straight. It will scatter. So that kind of thing is called as Tyndall effect. Next, the particles of suspension settles down when it is allowed to stand. So suspension is unstable. So particles you can see at the bottom, and it is also leave it for 10 to 15 minutes. All the particles come and settle down at the bottom. So it is unstable. It is not stable. Stable is this, the particles that doesn't settle down. Okay. Suspensions are either opaque or translucent. Here sand and water is translucent. It can be also opaque. The particles of suspension cannot pass through filter paper. Now try to filter this solution. It will come on the filter paper. It will not pass through the filter paper. So the particles of suspension cannot pass through the filter paper. So sand in water is suspension. Example, best example. Okay, next moving on to the colloidal solution. The colloidal solution, for the colloidal solution I have taken milk dissolved in water. I have added the milk in the water. So this forms colloids. Okay, now we'll go with the definition. What are colloids? The solution in which the size of particles lies between those of true solution and suspension are called as colloid. See, the size of particles, they are in between true solution and suspensions. Colloid is in between true solution and suspension. Once again, we'll go with the definition. Solutions in which the size of particles lies in between those of true solution and suspensions are called as colloidal solution. Example, starch in water, ink in water, milk in water. Take ink, dissolve in water, it will form a colloid. Now let's go with the properties. Properties of colloids. The colloidal solution appears to be homogeneous but it is heterogeneous. See, can you see the milk in the water? Yeah, it appears to be homogeneous. Yeah, you will be saying that it is homogeneous, but actually they are heterogeneous mixtures. We don't consider them in the homogeneous mixture. They appears to be homogeneous, but actually they are heterogeneous mixtures. The size of the particles lies between 1 to 100 nanometer, that is in between true solutions and suspensions. This is discussed. Colloidal particles passes through the ordinary filter paper. Now try to filter this solution. It will pass through the ordinary filter paper. Colloidal particles do not settle when left undisturbed. So they are stable. They are stable. We consider them as a stable because they don't settle at the bottom. So they are stable. Next, colloidal particles are not visible to the naked eye. Can you see the milk particles in this? No. So colloidal particles are not, they are also not seen with the naked eyes. Next, colloidal particle shows Brownian movement. Okay, what is Brownian movement? Brownian movement is the particles which are present inside it, they move in a zigzag manner. In the zigzag manner, this kind of movement is called as particles move in any direction, zigzag manner. So this kind of movement is called as Brownian movement. We'll go with the definition. Brownian movement, it is defined as the continuous zigzag movement of the colloidal particle in the colloidal solution. If we see under the high microscope, what we'll see, the particles of the milk, they are moving in a zigzag manner. Always they are moving in a zigzag manner. They will show the Brownian movement. Next, colloidal particles shows Tyndall effect. Tyndall effect is the scattering of beam of light by the colloidal particles. Means when you take the colloidal solution in a beaker and allow the light to pass through it. I am taking up the torch and allowing the light to pass through the colloidal solution. When the light passes through the colloidal solution, from the other side it will come in the form of scattering. The light will move in all the directions, scattering, in the form of scattering. This is called as Tyndall Effect. So these are the properties of the colloidal solution. Next, see, true solutions have two components. We have discussed that they have two components, that is solute and solvent. Similarly, colloidal solution also have two components. One is dispersed phase, the other one is dispersion medium. Okay, we also have two components in the colloidal. One is dispersed phase and other one is dispersion medium. In this dispersed phase is milk and dispersion medium is water. So we are going with the definition. We'll go with the definition of dispersed phase. Dispersed phase, the solute-like component which has been distributed throughout in a solvent-like medium. Okay, the solute-like component is milk in this, which is distributed throughout in a solvent, that is water. That is called as dispersed phase. The solute-like component which is present in the less amount is dispersed phase, and dispersion medium is which is present in the large amount, that is the solvent-like medium in which the dispersed phase has been distributed, called as dispersion medium. Okay, so colloids also have two mediums, that is one is dispersed phase and other one is dispersion medium. In this we have taken water and milk. Milk will come under dispersed phase and water will come under dispersion medium. So some more common examples, will go with the common examples. See, I am writing dispersed phase, dispersion medium, type and examples. Suppose the dispersed phase is liquid, means the solute part is liquid and the solvent part gas. Then the type means we called it as aerosol. Example are fog, cloud and mist. If you see the cloud, it contains liquid like water vapor and the gases. Okay. Similarly, solid plus gas is also called as aerosol. Example, smoke, automobiles, exhaust, etc. Gas and liquid is called as foam. Under this you will take the example of shaving cream. Liquid and liquid are called as emulsions. Example, milk and face cream. Solid and liquid are called as sol, like milk of magnesia, that is magnesium hydroxide, dissolved in water. Gas plus solid, we also call it as foam, like foams and sponge. Liquid and solids are called as gels. You can take the example as jellies, jelly which you eat, and butter. Solid and solid are called as solid sols, like milky glass. Have you seen the milky glass, colored gemstones? These are the examples. You have to learn this table. It can be asked for the 1 mark. What are aerosol? What are emulsions? What are foam? What is sol? What is gel? Give an example. If you get what are foam, then you will say that the foam is formed by the gas is made to dissolve in liquid. Okay, like dispersed phase is gas and dispersion medium is liquid. Example is shaving cream. Okay, you have to learn these types along with the dispersed phase, dispersion medium with examples. It can be asked in the marks. Today I am going to end my session till here. Thank you.